Welcome back, everyone, for another deep dive. This time, we're talking about something pretty big. Well, the biggest thing there is the end of the universe.
The end of everything.
Literally the end of everything. Thankfully, we have an expert to help us break this down. We're going to be talking all about the book, The End of Everything, Astrophysically Speaking, by Katie Mack,
Yeah.
which dives into all the ways that physicists and cosmologists think the universe might end.
It's a wild ride.
It is a wild ride through some pretty intense doomsday scenarios.
Yeah, but the fascinating thing is, by exploring these scenarios,
Yeah,
I think we can reveal something incredible about the universe we live in right now.
I like that. So sort of studying death to understand life, just
Yeah, exactly.
on a universal scale.
On a universal scale.
I like it. Okay, so let's start with some basics. The universe is expanding, right? It's not just sitting still.
Right. The universe is definitely not static. It's expanding. And that has, some really profound implications for its future.
So what does that mean for how it might all end? I mean, if it's expanding now, where does it go from there?
Well, I think a good starting point is to kind of visualize it.
Yeah.
Imagine the universe is like a giant loaf of raisin bread baking in the oven.
Okay.
As the bread rises, the raisins, which represent galaxies, all move farther and farther apart.
Okay, so everything is spreading out.
That's exactly what's happening with galaxies across the universe right now.
Yeah, and the further away something is, the faster it's moving away from us, right?
Exactly. That's, described by the Hubble-Lemaitre law. And it leads to another interesting point, because light takes time to travel.
Yeah.
When we look at these distant galaxies, we're not seeing them as they are today.
Right.
We're seeing them as they were billions of years ago.
Oh, wow. So it's like we're looking back in time?
It is like looking back in time when we look out into space.
That's amazing. So looking at a really, really distant galaxy is like looking at a baby picture of the universe.
Yeah, you could say that. And one of the most important baby pictures we have is something called the cosmic microwave background, or the CMB for short.
Oh, yeah.
And this is a faint afterglow of the Big Bang. It's a snapshot of the universe when it was just 380,000 years old.
Wow. I mean, it's just wild that we can see that right light from basically the very beginning of the universe.
It is pretty incredible, yeah.
But, okay, I thought the Big Bang was the beginning of everything. Was there something before the Big Bang?
Yeah, that's a really good question, and it's something that cosmologists are still debating. While the Big Bang explains a lot about the early universe, some theories suggest that it might not be the absolute beginning.
Okay.
The idea of a cyclic universe, where the Big Bang is just one stage in a never-ending cycle, of expansion and collapse, is a pretty interesting possibility.
So you're saying the universe can be like a phoenix, constantly reborn?
Some physicists believe that's possible.
Okay, so we have this expansion happening, and we don't even know for sure if the Big Bang was the beginning, but we do have this baby picture, this CMB, to look back on.
Yeah, we do, and it's more than just a pretty picture. It tells us a lot about the universe's evolution.
What do you mean? What can we learn from this cosmic snapshot?
Well, for starters, it reveals a lot about the conditions of the early universe.
Mhm.
It tells us about its temperature, its density, and its composition.
Wow.
And then, by studying the tiny, tiny variations in the CMB, we can actually understand how the universe evolved from this incredibly hot, dense state
Oh, okay.
into the complex structures of galaxies and stars that we see today.
Okay, so it's a blueprint. It's like a cosmic blueprint.
In a way, yeah.
That's awesome. This is really making me appreciate microwave radiation in a whole new way.
I'm glad to hear it.
All right, but we got to get back to the topic of the day, right? How does all this end? Where does the expansion lead us?
Well, one possibility is what's called the Big Crunch. Now, just imagine if the expansion of the universe were to reverse.
Okay.
Kind of like, like a ball thrown up in the air that eventually falls back down.
Okay, because of gravity.
Right, due to gravity.
Ah.
And everything would start to come back together.
So instead of spreading out, galaxies would start rushing toward each other.
That's the idea.
Okay, whoa. What would that look like? I mean, would we even notice at first?
At first, the changes would be pretty subtle. But gradually, the redshift of distant galaxies, that stretching of light that tells us they're moving away,
Yeah.
that would start to decrease.
Oh.
They start to appear bluer instead of redder as the universe contracts.
Oh, wow. So instead of redshift, we'd see blue shift.
Exactly.
Okay. And then things would start to get really crazy, right?
Yeah. As the universe contracts further, galaxies would start to collide and merge. I mean, think about the chaos.
Oh, man. Yeah, that would...
Stars would be flung around. Black holes would be gobbling up anything in their path. It would be a truly spectacular and probably terrifying cosmic show.
Oh, definitely. And what about the CMB? What happens to our baby picture in this scenario?
Well, that's where things get even wilder. Remember how the CMB is really faint? Just a faint microwave radiation now?
Yeah.
Well, in the Big Crunch, it wouldn't stay faint. As the universe shrinks, all that radiation gets compressed, you see,
Okay.
and the wavelength shortens, which means it becomes more and more intense.
Oh, wow. So it's like taking that quiet hum and just turning up the volume?
You could think of it that way, and eventually it becomes so intense that it could actually ignite the surfaces of stars.
Whoa, wait. So starlight would set stars on fire?
That's the idea.
Yeah. That's insane.
Yeah, it's pretty mind-blowing.
So it's not just everything crashing together. The universe is also getting hotter and hotter because of this intensifying background radiation.
Exactly. It's the ultimate cosmic meltdown.
Okay, that's definitely one way for things to end. But I have a feeling there are even more bizarre ways the universe could go out, right?
Oh, absolutely. We've only just begun to explore the possibilities.
Let's dive into those next.
Yeah, the Big Crunch is, it's pretty dramatic, but there's another scenario that's even more unsettling.
Okay.
It involves the idea that, the universe we know, with its stars and galaxies and everything, is fundamentally unstable.
Oh, wow.
It's kind of like a house of cards, carefully balanced,
Okay.
just waiting for, the slightest nudge to send it all crashing down.
That's a pretty vivid image.
I'm-
What's this cosmic house of cards built on? What could cause it to collapse?
It all comes down to the Higgs field.
Okay.
You've probably heard of the Higgs boson.
Yeah. The God particle
Right.
discovered back in 2012.
Yeah, big scientific breakthrough, right?
Huge. Yeah, they even made a movie about it.
Yeah. And, that discovery was about much more than just a single particle.
Okay.
It actually confirmed the existence of the Higgs field, which is an energy field that permeates all of space. And it's what gives other particles their mass.
So this Higgs field is like, it's everywhere, all around us,
Yeah.
even though we can't see it.
Yeah, you got it.
Okay, and it's responsible for mass, for things having weight and substance.
That's the basic idea, yeah. But here's where things get really interesting.
Okay.
The Higgs field could actually exist in different states.
Okay.
Kind of like, like water can exist as ice, liquid, or steam.
Right.
And the state it's in now, the one that allows for, atoms and stars and galaxies to exist, might not be the most stable one.
Wait, are you saying that the Higgs field could, like, change states? Like water turning to ice?
Yeah, that's the unsettling possibility.
What would happen if it did?
Okay, well, think of it like this. Imagine a valley
Huh?
with a small dip on one side and then a much deeper valley at the bottom.
Right.
A ball resting in that small dip that represents the current state of the Higgs field. Okay. It's relatively stable, but if something were to just nudge it a little bit,
Yeah.
it could roll down into that much deeper valley.
Okay, so the Higgs field is in this delicate balance.
Right.
But what could nudge it into a different state?
Where it could be something as seemingly insignificant as a random quantum fluctuation.
Okay.
Just a tiny ripple in the fabric of reality.
And when that happens, when the Higgs field rolls into that deeper valley, what happens then?
That's when we have what's called vacuum decay,
Vacuum decay.
a bubble of what we call true vacuum,
Hmm.
representing this lowest energy state of the Higgs field, would form,
Okay.
and it would expand outward at the speed of light.
At the speed of light. A bubble of true vacuum. That sounds kind of ominous.
It is pretty ominous.
What would that even look like?
Well, it wouldn't be like an explosion or a collision. It would be more like the universe just being rewritten with new rules.
Okay, so inside this bubble,
Yeah.
the laws of physics as we know them just wouldn't apply anymore.
Exactly. Inside this bubble, particles wouldn't have mass, atoms couldn't hold together, and everything we're familiar with would just, it would cease to exist.
So it's not like the universe is destroyed. It's like it's just deleted, like gone without a trace.
In a sense, yeah.
Okay, yeah, you were right. That is more unsettling than the universe being ripped apart or something.
It's a pretty bleak scenario.
Yeah. Is there any way to know if this is going to happen? Like, are there any signs we should be looking for?
Well, it's a very difficult question to answer,
Yeah.
but the good news is that vacuum decay is considered incredibly unlikely.
Okay.
The Higgs field, it seems to be fairly stable, at least for now.
Okay, so we don't have to start panicking just yet.
No, not at all. I wouldn't lose sleep over it.
Okay, good. But it does make you think. right?
It does.
About how fragile our existence might be
Yeah.
based on, the delicate balance of this invisible energy field.
Right. This thing that we can't even see or touch,
Yeah.
but it's permeating everything.
Yeah, it's a lot to process. It's like the universe is vast and ancient, and yet, it could all go away in an instant.
It really puts things into perspective.
It does, but okay, this whole idea of the Higgs field and these different states, it raises another question for me.
Okay.
Could there be other universes out there?
Oh, the multiverse.
Yeah, with different Higgs fields, different laws of physics.
Yeah, the idea of the multiverse, it's a very compelling one.
That's my kind of deep dive. Are there any theories that actually suggest other universes might exist?
There are, actually. One model that leads to the idea of other universes is called the ecpyrotic universe.
Ecterotic universe.
Pretty mind-bending concept, so get ready.
Challenge accepted. Let's hear it.
Okay, so imagine our universe as a three-dimensional brain
Okay.
existing within a higher dimensional space.
All right, so kind of like a sheet of paper floating in a room.
Exactly. A sheet of paper floating in a room. And now imagine that there are other brains, other universes
Okay.
also floating in this higher dimensional space.
So it's like a stack of sheets of paper, and each sheet is a different universe.
Yeah, you can visualize it that way.
What happens in this multi-brain universe?
Well, these brains could actually collide with each other.
Oh.
And in the ecpyrotic model, the Big Bang itself
Yeah.
could be the result of a collision
Bro.
between our brain and another one.
Wait, so you're saying the Big Bang, the event that created our universe, was actually a cosmic fender bender
It's one way to think about it.
between two universes?
Yeah. I mean, the energy from this collision would be so immense that it would create, the hot, dense state that we associate with the Big Bang.
Okay, so instead of a single beginning,
Right.
we have this eternal cycle of universes colliding and
Right.
creating new universes.
It's a linear model of the Big Bang.
Yeah,
It suggests that our universe might just be one chapter
yeah.
in a much, much grander cosmic story.
I love that. It's like the universe is constantly renewing itself. But is there any evidence to support this ecpyrotic model?
Well, finding evidence for any model of the early universe is a huge challenge.
Yeah.
But there's some tantalizing possibilities.
Okay.
The ecpyrotic model predicts specific patterns in the cosmic microwave background
Okay.
that we might be able to detect with more advanced telescopes.
So those baby pictures of the universe, they could hold clues to a much bigger story.
They could, yeah.
Maybe even a multiverse. That's incredible.
And it's not just about what happened in the past, understanding the ecpyrotic model and other models like it
Yeah.
could also help us figure out the ultimate fate of the universe.
Okay. This is all so fascinating, but I feel like we've barely scratched the surface. There's
Yeah.
so much more to explore.
Absolutely.
And one of the biggest mysteries we still need to unravel is dark energy, right?
Yeah, dark energy, it's a big one.
That's the mysterious force that's causing the universe to expand at an accelerating rate.
Right, exactly.
And it seems like dark energy holds the key to understanding how this whole cosmic story ends.
Yeah, it really does.
So what can you tell us about it? What is dark energy?
It's amazing to think about all the different ways the universe could end. The big crunch, vacuum decay, colliding universes. It really makes you realize just how much is out there and how much we still don't know.
It's humbling, isn't it?
It is, but it's also exciting. Figuring out how the universe might end is also teaching us a lot about how it works right now.
Exactly. The search for answers about the universe's fate leads to all sorts of discoveries, things we might never have found otherwise.
Like dark matter and dark energy, right?
Exactly. Those discoveries came about because we were trying to explain the universe's expansion, which is, fundamental to understanding how it all might end.
Right. So far, we've been talking about observing the universe on this massive scale, looking at galaxies that are billions of light years away.
Right. Trying to map the expansion of the universe and the influence of dark energy. But are there other ways to study the universe and its fate? Like, what about zooming in on the really small stuff?
That's where particle physics comes in. Particle accelerators, like the Large Hadron Collider, allow us to smash particles together at incredibly high energies,
Oh, wow.
basically recreating the conditions of the very early universe.
So they're like creating tiny big bangs in the lab.
You can think of it that way.
That's amazing. What can they learn from doing that?
Well, these experiments provide incredible insights into the fundamental building blocks of matter and the forces that govern them.
Okay.
It's like, taking apart a clock to see how all the gears and springs work together.
Yeah, I get it. So how does understanding these tiny particles and these, fundamental forces, how does that connect to the bigger picture, to the fate of the universe?
Well, one of the biggest goals in physics is to find a unified theory that explains all the forces of nature, gravity, electromagnetism, the
Mhm.
strong and weak forces. This theory of everything,
Yeah.
it wouldn't just give us a deeper understanding of the universe's fundamental laws.
Right.
It might also shed light on the nature of dark energy and ultimately the fate of the cosmos.
So we're trying to connect the very small to the very large, the world of particles, to the world of galaxies and expanding space.
Exactly.
And if we can, crack that code,
Yeah,
we might be able to unlock the secrets of the universe's destiny.
that's the hope.
Wow. That's pretty profound.
It is. And, some physicists are exploring some truly mind-bending ideas in this pursuit.
Okay, like what?
Well, for instance, some believe that space-time, the very fabric of the universe,
Yeah.
might not be as fundamental as we thought.
Wait, are you saying that space and time might be illusions?
Well, maybe not illusions,
Okay.
but it might be emergent properties
Okay.
of something more fundamental, like information.
Information. So information is the building block of the universe.
It's a radical concept, I know, but some believe it holds the key to understanding, the quantum nature of gravity and the origin of space-time itself.
So if this is true, our understanding of the Big Bang, the expansion of the universe, even the very concept of beginning and end, it all might need to be rethought.
It's a possibility, yeah.
Wow. That's a lot to take in. It's like we're at the edge of a whole new understanding of the universe.
And that's the beauty of science, isn't it?
Eh.
The more we learn, the more we realize how much more there is to discover.
Well said. Well, it's clear that this quest to understand the universe from its beginning to its end, it's a journey that will probably continue for a very, very long time.
Absolutely, for generations to come.
Exploring all these possible endings, it really makes you think about our place in this vast cosmos.
It does. It's a good reminder that even though our individual lives are fleeting, we are part of something much larger than ourselves, something that has existed for billions of years and will continue to exist long after we're gone.
That's a comforting thought, actually.
Yeah, I think so too.
Well, thanks for taking us on this epic journey to the end of everything.
It's been my pleasure.
We'll be back next week with another deep dive into the mysteries of the cosmos. Until then, keep looking up and keep wondering.